So I will talk about the OpenPOWER Hub at the University of Oregon. My name is Shinde, as you know. I am a research professor at the University of Oregon and the director of the Performance Research Laboratory and the interim director of our OSS group at the University of Oregon. Now, we heard about the OpenPOWER Hub. I'll not repeat any of that and all the advantages of why you should sign up to be a member of the OpenPOWER Foundation. I was going to show a demo of our system, but Siva already did that. He logged into the University of Oregon system and he showed the whole demo of the DB2 workflow and how we have been collaborating. Now we are interested in collaborations. We are a team of computer scientists, unlike the CQLS team with a lot of domain expertise. We have expertise in computer science. By training, I'm a computer scientist. I got my PhD in computer science more than 20 years ago. We have a whole team of computer scientists. Professor Alan Maloney is a professor in the computer science department. We work for the exascale computing project. As you saw, the extreme scale scientific software stack. So we are interested in performance evaluation tools, system software development, the entire software stack for OpenPOWER. And that's where our core expertise is. We also have a lot of people who have expertise in GPU runtimes, instrumentation of those in networking technologies. And you'll see a focus on networking in our infrastructure at the University of Oregon. First of all, our systems are connected to internet by a 100 Gbps link to the data center. 100 Gbps to internet to, we have a Juniper switch with 100 Gbps backplane. We have a GS4S high performance data system for a file server with 1200 Gbps links to our Mellanox switch and very high I/O rates with GPFS or IBM Spectrum scale. We have many different file systems. We have NFS, we have the Spectrum scale GPFS, we have BGFS. We also have other specialized NVMe drive-based systems. And also we have obtained 200-based high memory NVMe systems. So we have a lot of systems with data analytics capabilities with GPUs. We have AC922 systems. We have 4 of those IC922s. We have Talus workstations. So we have a variety of different Power 9 processors. Instead of just providing a single kind of Power 9 system, we have processors with right from 10 cores to 16 cores to 20 cores and beyond. And you can compare the performance. You can look at the different memory architectures. You can look at the networking. And this is really important. We have 100 Gbps InfiniBand in our AC922s. And we are running MVAPIC2. We are running those protocols for high performance data throughput. We, of course, have 4 of those V100 GPUs in that. We have other systems with A100 GPUs as well. And more importantly, we have systems with AIX, because I mentioned a lot of interest in working on computer science related research. We have AIX, we have VIOS, so that we can move the curtain between the Linux and the AIX. Now, IBM is one of the few vendors which provides that capability, where you can just dynamically allocate memory and processors and say, I need 256 GB RAM and I need 16 cores to run AIX and the rest of them to be allocated to Linux. So those capabilities, where you dynamically move the partition between AIX and Linux, those capabilities are available on S924 systems, not AC922s, but S924s. And we have Power 8 systems with even K80 GPUs for legacy applications and running those things. Now, instead of having systems like if you go to Summit or one of these large supercomputing centers where there are a lot of domain scientists working, you may have a hard time getting access to the nodes. You may be stuck behind a batch system. That is one thing that doesn't happen at the University of Oregon. Our basic work involves computer science research. So our systems are not loaded with 20,000 jobs running on those. Instead, you can get ready access to bare metal systems, which is a unique point at the University of Oregon with very high networking throughput. That's our key. 100 Gbps between the nodes, 100 Gbps to the internet. That is a key differentiator with very large number of options for I/O, where you can see the local I/O on local SSDs versus BGFS versus GPFS versus NFS on a variety of different systems. Our systems are collectively called Frank, in short for this Frankenstein. And you can see exactly what kind of systems we have here. And you can see Medusa, Typhon, Power 9, with different configurations, with AIX systems running AIX 7.2. We can see that there are 20 core Power 9s here and other configurations. And you can look at the systems. You can see even other Intel-based systems with networking connections between the two. And you can look at the processor architecture and so on, and where it is located. So we are interested in collaborations. If you are in a company or some organization that is part of OpenPOWER Foundation, and you are interested in working with computer scientists with a strong background in system software, we want to hear from you. We want to get you in touch with the experts in IBM who can answer the questions about technologies that they are more well-versed with. We can get you access to the systems and software that IBM provides on these systems. We also have a site license for Red Hat. So our systems are running Red Hat Enterprise Linux 8.6 in many cases, because University of Oregon has a Red Hat site license. So open source software stacks, containers, GPUs, high performance networks, IO, memory options, all of those are our skills. And if you are interested in learning more about what the Exascale Computing Project is doing, especially with Summit, Sierra, and other technologies, please talk to us. Let us know how we can help you, because we are the developers of tools like the Tau Performance System and the Extreme Scale Scientific Software Stack. So with that, thank you very much, Ganesan. And if there are any questions, I'll take them now.
Do you guys have a booth here?
I do not have a booth here, but we work with the Department of Energy. So yes, of course.
You'll be sure.
Also, the area of the virus going to be at the
Yes, please stop by the OpenPOWER booth at SC, all of you attendees, and learn more about our technologies and programs. Thank you. That's a very good point. We are also involved with the chips development. We also have FPGAs. If you go and see here, you'll find some power systems with Bitware 250 SoC cards for FPGAs, very powerful FPGAs, as well as a whole system, a lab with FPGA A7100 RT systems, where we have a full environment, the software stack for developing OpenPOWER technologies. And you'll see microwatt A2I, A2O cores being used in such technologies, and the workshop that was held recently at Virginia Tech. So we provide access to those FPGAs for designing chips that may include the OpenPOWER cores in them. and you'll be able to simulate them on the FPGAs and use them. So thank you for pointing that out, Garrison. Thanks. Bye.